All right, so what we'll consider here is perpendicular lines. So when we have two lines that dissect each other where they form a 90-degree angle, we can calculate their slope and have a look at the relationship of these two lines and their slopes, and then make predictions about other lines, which we'll have a look on the right-hand side of the Cartesian planes. So let's first go ahead and we will label these particular lines, C and D, line segments, and then E and F. So better notation shows that because it's a line segment, it should have a point or a letter denoting its start and finish. So let's go ahead and say that we know, or we are predicting, that these are right angled, and we're going to use their slopes to see whether they are or not. So let's go ahead and work out the slope of line segment EF. If we take the run first, we can see the run is equal to 3 units, and then the rise is equal to 6 units. This means that the slope of line segment EF is equal to 6 over 3, or simply 2 over 1. Secondly, what we need to do is establish the slope of line segment CD. Now, if we do this in a slightly different color so we can see the difference, we'll start with the rise, which we can see is 3 units. However, we've moved in a negative direction. So when we move down the Cartesian plane, this direction is a negative. So we end up with a -3 rise. We move to the right, which is a positive move. And when we consider the run, we see that we've moved we've moved 6 units. So we write that down, therefore we have the slope of segment CD is equal to -3 over 6, which is equal to -1/2. Now, if we take a look at these two answers, what we can see is some things that are very in common. What we can see is they both have a 2 and they both have a 1. However, one is in the numerator spot and one is in the denominator spot. So what we would call these are reciprocals. So -1/2 is a reciprocal of 2 over 1. And because we can see that they are opposites, 2 over 1 is a positive. And we can see -1 over 2 is obviously a negative. And we can see that the 2 has been moved to the denominator spot and the 1 has become the numerator. So therefore, if two lines are truly perpendicular and we're able to work out their slopes, what we should see is that one slope is the reciprocal of the other. So in summary, you can see that 2 over 1 is positive, and this is equal to the line segment EF. What we have is a -1/2, which is equal to line segment CD, which means we can write that EF is perpendicular to CD because their slopes are reciprocals.